In Chapter 15, we're going to be talking about intravenous solutions, equipment, and calculations. The abbreviations used are D for dextrose, W for water, S for saline, NS is for normal saline, NaCl is sodium chloride, RL is a Ringer's lactate, and LR is a lactated Ringer's. Normal serum osmolarity, I suppose, is how it's pronounced. Hypotonic, you used to dilute excess serum electrolytes, such as 4,500% saline. Isotonic is used to expand volume and maintain normal tonicity, such as 9/10% saline, lactated Ringer's, 5% dextrose. Hypertonic is used to correct electrolyte imbalances, such as 5% dextrose, 9/10% saline, 5% dextrose, and lactated Ringer's. The IV sites, peripheral, is the rate of infusion should not exceed 200 milliliters in 1 hour, and a central line accommodates larger concentrations and volumes of fluid. The complications that you can have from an IV site is phlebitis, infiltration, and infection. This is a straight gravity flow IV. This is the IV bag, the injection port, the drip chamber, and the roller clamp. This is an IV with a piggyback. It's where it can give antibiotic or blood. It's attached here. The IV flow rate is ordered by the physician, and the nurse's responsibility to regulate, monitor, and maintain the flow rate. The IV flow rate is in milliliters per hour. So we regulate an IV volume by electronic infusion pump or controller calibrated in milliliters per hour. So the total milliliters ordered over the total hours ordered is the milliliters per hour, rounded to a whole number. So the calculation of an IV flow rate in milliliters per hour would be if the order reads D5W250 milliliters IV over the next 2 hours by infusion pump. This is dextrose 5%, water 250 milliliters. The calculation of IV flow rate in milliliters per hour, in step 1 you think the pump is set by the rate of milliliters per hour. So if 250 milliliters is to be infused in 2 hours, how much will be infused in 1 hour? So you take 2, divide it into 250. So you know 125 milliliters will be infused in 1 hour. So you would set the pump at 125 milliliters per hour. The IV flow rate in milliliters per hour, step 2, is use this formula. The total milliliters ordered divided by the total hours ordered gives you milliliters per hour. And this is how you would set up the problem in the previous situation. Now, if the IV flow rate is in milliliters per hour, but the infusion rate is less than 1 hour, then we need to change to minutes. And we can do that by multiplying the milliliters ordered divided by the minutes ordered times 60 minutes per hour. And you round this to a whole number. So an order might say ampicillin 500 milligrams IV in 50 milliliters, dextrose 5%, 1/2 NS normal saline in 30 minutes by controller. So the calculation rate would be step 1. The controller is set by the rate of milliliters per hour. So if 50 milliliters is to be infused in 30 minutes, then 100 milliliters would be infused in 60 minutes. Because 100 milliliters is twice as much as 50 milliliters, and 60 minutes is twice as much as 30 minutes, set the rate of controller at 100 milliliters per hour to infuse 50 milliliters per 30 minutes. So the milliliters ordered was 50. The minutes ordered was 30 times 60 minutes per hour, and that's 100 milliliters per hour. If the IV flow rate is drops per minute, the formula for the IV flow rate for manually regulated IVs ordered in milliliters per hour or for minutes is the volume in milliliters divided by the time times the calibration or the drops per milliliter, and that gives you your rate per minute. So you carry your calculations to 1 decimal and you round drops per minute to the nearest whole number. And then you watch. You count only whole drops. So if the physician ordered dextrose 5% water IV at 125 milliliters per hour, the infusion set is calibrated for a drop factor of 10 drops per milliliter. So you calculate the IV flow rate in drops per minute. Notice that the milliliter cancels out, leaving drops per minute. So it looks like this. The order was 125 milliliters in an hour, which is 60 minutes, times 10 drops per minute, or per milliliter. And so the milliliters cancels out, and then you get 20 8/10 drops per minute. So you use your watch to count drops and adjust the roller clamp so that you deliver 21 drops per minute. If you're dealing with the micro drip drop factor, so when the IV drop factor is 60 drops per milliliter, then the flow rate in drops per minute is the same as the volume ordered in milliliters per minute. Or excuse me, milliliters per hour. So the calculation of drops per minute by the micro drip drop factor, if the order is dextrose 5%, water, normal saline IV at 50 milliliters per hour, and the drop factor is 60 drops per milliliter. Notice the order is 50 milliliters per hour is the same as the flow rate of 50 drops per minute when the drop factor is 60 drops per milliliter. So if the order is 50 milliliters per hour, that's 60 minutes, at 60 drops per milliliter, the milliliters cancels out, the 60 cancels out, and that means it would be 50 drops per minute. So here's your drop factor constants. If the drop factor is 10 drops per milliliter, the constant is 6. If it's 15 drops, it's 4, and 20 drops is 3, and 60 drops is 1. So if you have 125 milliliters per hour IV and 20 drops per milliliter infusion set, you set up your problem as what is ordered over 60 minutes, the drop factor, milliliters cancels out, and you have 125 drops every 3 minutes, or rounding to the nearest whole number is 42 drops per minute. So the shortcut to calculate IV flow rate is to take the milliliters per hour divided by the drop factor constant, and that will give you the drops per minute. Check for institutional policy regarding correcting off-schedule IV rates and the percentage of variation allowed. Variation should not exceed 25%. If adjustment is permitted, use the following formula to calculate the milliliters per hour and the drops per minute for the time remaining and the percentage of variation. So in step 1, you take the remaining volume divided by the remaining hours. So that's the recalculated milliliter per hour. So you take the volume divided by the time times the drop rate, and that gives you the drop rate per minute. So then you take your adjusted drop rate per minute minus the ordered drop rate per minute divided by the ordered drop rate per minute, and that gives you your percent of variation. Your percent of variation will be positive if the administration is slow and the rate has to be increased, and it will be negative if the administration is too fast and the rate has to be decreased. So if the order was 500 milliliters LR to run over 10 hours at 50 milliliters per hour, so the drop factor is 60 drops per milliliter, and the IV is correctly infusing at 50 drops per minute. After 2.5 hours, 300 milliliters is remaining, so almost half of the total volume infused in 1/4 of the time. So the IV infusion is ahead of schedule. So you compute a new rate of 300 milliliters to complete the IV fluid order in remaining 7.5 hours. So the patient would require close assessment for fluid overload. So the remaining volume divided by the remaining hours is 40 milliliters per hour. So 40 milliliters is the volume, the time is 60 minutes, and you want 60 drops per milliliter. So your adjusted flow rate would be 40 drops per minute. So the adjusted drop per minute, 40, minus what was ordered, 50, divided by what was ordered, gives you a negative 20%. So you're slowing it down. The caution on the IV push rate calculation: IV drugs are potent and rapid acting. Never infuse IV push drugs more rapidly than recommended. Some drugs require further dilution after reconstitution, so read the package inserts and drug resources for administration guidelines. Remember, you take the desired dosage divided by what you have times the quantity of time recommended, and that's the IV push rate. So if you have Ativan 3 milligrams IV push 20 minutes pre-operatively, and your supply is Ativan 4 milligrams per milliliter, with drug literature guidelines of IV infusion not to exceed 2 milligrams per minute, how much Ativan should you prepare? So first, there's no conversion necessary. So you think, are you going to give less than a milliliter or more? And then you prepare. What is desired is 3 milligrams. What you have is 4. And the dosage is 1 milliliter. Or the quantity is 1 milliliter. So that means you're going to give 7/500 milliliter. So how much should you infuse every 15 seconds? Well, 1 minute is 60 seconds. A minute and a half is 90 seconds. So you have 1.5 minutes as the safe infusion time.